Today we're just going to kind of talk about what we do with Corps of Engineers in the regulatory department, how we do things, why we do them, where we get our jurisdiction from. As Charlene said, in 1899 the Rivers and Harbors Act was enacted. That gave us the authority to manage navigable waters. Typically that's all waterways that have tidal influence. You have the ebb and flow of the tide, and that all comes back to commerce because, as everybody knows, everything runs around money. So we want to make sure that all the ships and everything can get where they need to go. Then, later in the 1970s, we had the Clean Water Act come around. That gave us more authority to extend past the tidal influence of waterways to other water bodies that affect navigable waters and commerce later on down the stream. So navigable waters, as I said before, are those waterways that are subject to the ebb and flow of the tide. That is true for the majority of the cases. There are a few exceptions to navigable waters where we would also have jurisdiction. For example, an impounded area, there's a dam. Maybe at one time it was tidal, now it's not anymore, but we still have that authority because it does interact with interstate commerce. The Mississippi River, that's another example. As you get farther north, it's not tidal anymore, but it's still transporting goods between states. Waters and wetlands that are Section 404, those are the waters and wetlands that are adjacent to navigable waters or that flow into them. So once you hit the high tide line, you may have a marsh and a wetland that's not daily flooded, but it's still a wetland area, or streams in the mountains, ponds that someone maybe has on their farm or in the woods by their house. Those all eventually flow into the rivers. One exception to our jurisdiction are isolated wetlands. Those are ones that have absolutely no interaction with navigable waters. So if you were to go into the middle of a field and dig a hole and it filled up with water because it doesn't go anywhere, that would not be within our jurisdiction. This is kind of an example of showing you how our jurisdiction can change. You have a tidal system here and a non-tidal area. The Section 10 jurisdiction goes up to the high tide line or the ordinary high water line. And then the Section 404 is all the wetlands beyond those. Okay, these are some examples of different permits that we would issue to someone that wants to build something within one of our jurisdictions. Under Section 10 for navigable waters, we typically issue permits for structures that might impact navigation. So if someone wants to put a pier in, you'd want to make sure that the boats aren't running into them. Same thing with dredging, you want to make sure that the boats can get in and out efficiently. Section 10 and 404, that's also for within our tidal areas, but it has to do with fill material, not structures being built. So riprap, that's when someone wants to take quarry stone rocks and put them along the shoreline to stabilize it, bulkheads, things like that. We would get your jurisdiction under 404 and 10. Bridges are the one exception to that. The Coast Guard has authority to issue permits for all bridges unless there is a fill component with it. So if they have to come in and put some riprap or some extra dirt along the footers or on the sides of the bridge, then we would also get involved. And then lastly is our Section 404 only. That's for everything above the tidal and navigable water systems. So common developments, residential housing, commercial buildings, road crossings, we all have jurisdiction to issue permits under 404. Here's a few examples of Section 10 and Section 404 projects. You have our piers, that would be a structure, the riprap. This is one of the dredges that we have that dredges our federal channels. That was probably one of the neatest ships I've ever been on before. What they do is when they're dredging the waterways, they create a slurry with all the sediment they're sucking up with the water. It dumps into the middle of the boat and the water all drains off. Then they go over to a disposal site and the entire boat splits in half and all the material falls out the bottom. So it's kind of scary the first time you're on there and you're thinking you're floating on water and there's a giant hole in the boat. Now, this is one you're probably a little more familiar with. This required permits under our Section 10 and 404 because we have the tidal wetlands out here, and then there were some non-tidal areas that had happened where the bulkhead had eroded away. And then here's an example of a 404 project. Remember all that smoke you had to smell over the summer from the Dismal Swamp? That was one of my fun projects. I got to go out there during the heat of it all, and it was really interesting. But what we would regulate, because obviously Mother Nature, you can't control her, so we can't tell her what to do, We work with Fish and Wildlife for all the techniques that they have to use to fight it. So when they have to come in and fill ditches and block them, that's all mechanical work that they're doing. So we have to make sure that once the fire's under control, everything is back to normal almost, then they have to make sure they restore whatever they intentionally impacted. Alright, so when you think of a wetland, this is typically what you would probably think of. You look out here, that's kind of an obvious one. Some other examples, you have Virginia Beach, a swamp, a river system. But what about these? If you were to go walking through the woods and see something like this, would you typically think that's a wetland? All four of these are different types of wetland systems. And it's our job, which this is the harder part, is determining if it is a wetland, if it meets all the parameters, or if it doesn't. So the way we determine that is based off of 3 parameters dealing with water hydrology, the types of vegetation growing there, and the soil conditions. So hydrophytic vegetation, we have to look at all the different plant species that are growing there. And if the majority of the plant species are likely to be wetland plants, or definitely wetland plants, then it falls into that hydrophytic vegetation category. If most of the plants typically grow in upland areas all the time, then it wouldn't meet that parameter. Hydric soils. The soils change when they have water in them for a while. They tend to get darker, iron deposits in there start to bleed, and you get rust staining. Whereas if it's non-hydric, it tends to be a brighter color, kind of like clays when you go to the mountains versus the dark peat when you go to the swamps. And then hydrology, that can be the easy one sometimes. If you have standing water out there, you start getting water lines, the leaves turn black, or maybe the plants start growing different. If you look at a cypress swamp, the roots tend to grow out and buckle up more, but you wouldn't normally see that a lot in an upland area. So here's some examples of the wetland hydrology features. You have the water staining, the blackened leaves, the standing water. Here's an example of the soils. As you can see, it starts here with the hydric soils where it's darker, and as it gets lighter, you get closer to an upland area. And we have a book that we use when we're in the field, so we have to dig holes, and we compare the soils to this chart. If the main background color falls into this category, most of the time it meets the hydric soil parameter. And that can get kind of tricky in our area because there are a lot of low floodplain areas, swamps. So a lot of times the soils will tend to meet because you are near the ocean. And it gets a little easier as you get farther west because then it's closer to the water bodies, the streams, and the creeks. And then we have our vegetation. You have the obvious ones like lily pads, cypress trees. And then it gets really tricky as you have to know hundreds and hundreds of plant species that even us, we end up scratching our heads and having to pull books out and key them out. So that's always fun. So basically that's what we do, how we do it. It's quick and simple. And does anyone have any questions?